Good day, students. So we'll be continuing from our previous exercise. So in the last exercise, right, we did exercise number one, right? So yeah, if you want to recap on how that went, like you should go back to exercise number one. So in exercise number one, we went over how to define a center and went over how to move the robot to reach a particular position, how to save that position, right? And I also taught you a method, right? That like if you already have the position, you can just type the positions onto your teach in, right? And then from then on, that's when you can save that position and come here and you insert it, right? So went over, so if I can just minimize this for the time being. So went over two types of sensors, right? Went over two sensors in the last exercise. So two sensors that we're dealing with was the part AV sensor and the material detection sensor, right? But like, but since but how or the only sensor that we've used up until now, like it's the part AV sensor, right? So now we'll be using the material decomposition sensor in some of the exercises, right? So and then here I told you when after you've defined your sensors that you're gonna be using in the exercises, the second thing that you have to do, you have to set the speed of the robot, right? So you always set the speed of the robot, right? So and also explained in the previous video, like why did I put it at 5, whatnot. So you should also go back and look at that, right? And then I also explained this line, right? So this line, it's for ensuring that the robot, if the part AV sensor, so the part AV sensor, it's a binary sensor or it's a digital sensor in a manner of speaking, right? So it exists in two states, right? It can be either be 0 or 1, right? So now here you are saying while the part AV sensor is 0, right? You're gonna trap the robot in this loop, right? Which means the robot is gonna wait in this position up until it detects a workpiece, right? And then from then on, like after it detects the workpiece, which means part AV will become 1. That's when this loop will be broken, which means if the robot like suddenly detects a workpiece like this, as you can see, the loop is broken, right? But if I remove the work, like if I now, let's say, as you can see, the robot is trapped in this loop because no workpiece is detected. It only breaks this loop of staying in this position up until when it detects a workpiece. That's when the loop is broken, right? So, yeah. So now we'll be moving on to exercise number two, right? So in exercise number two, so this is exercise number one, so this is exercise number two, right? So here, right, the description of the problem is saying the functional testing of the robot has been successfully completed, and then production production management would like to be introduced to the new station, right? And they're saying your team leader has asked you to create a simple application for use in a presentation, right? So, and then they gave you an operating sequence, right? So an operating sequence, like talks about or it identifies the types of sequences, right, that the robot is supposed to take, right, to complete that particular work cycle, right? So now they are saying the robot waits up until it receives a signal from the part AV sensor indicating that the part is present, right? So we have already done that, like with this loop, right? So yeah, so the robot is gonna wait up until it detects the presence of a workpiece. That's when it's gonna detect this loop, right? And then the gripper opens, right? So we've also opened the gripper. So we can also put this like here, cause okay, no, it's fine here. It's fine here, right? Or let's just remove it here and follow the operating sequence one. So they're saying the gripper opens, right? So we'll comment, say opening the gripper, right? So we'll age open one, right? So we'll open the gripper, right? And then after opening the grip, before the robot moves, we'll delay for 2 seconds, right? So just delay DLY for 2 seconds, right? And then now, what's the next work cycle, right? So the next work cycle is saying, or the next step is saying, the robot advances to the workpiece such that it can grasp the workpiece, right? So now we have to move to grasp the workpiece, right? So if I can press play here, right, and then I'm gonna insert a workpiece, right? So now we have to now move to grasp the workpiece, right? So which means now we have to go there to grab the workpiece, right? So now, as I also explained, like in the previous video, between the what you call between the different moves, right? So we have MOV and MVS, right? So I also explained like what do these moves does, and that's the importance of using these moves. Like so, yeah, I taught you how to use them strategically, right? So now, since here there's no obstacles, right? We can just use an MOV where we move straight to grab the workpiece, right? So let's say now I'll comment here, moving to grasp the workpiece, right? So now we're still using also uh, the same coordinates, right? So our P1 is where we collect our workpiece. Our P100 is our home position. Our P2 is where we test the position, and then our P3 it's where we're testing the workpiece, and then our P4 is the assembly slot number 2, right? So we're still using the same positions as well, right? So now I'm gonna go back. So let's say like you are trying to view all of these things at once, right? Or they're covering the screen. That one way you can reorganize them. You can just go to window, right? And then you're gonna choose tile vertical, right? So as you can see now, they are more easier to work with, right? So since we're also, let's say I want more screen for a robot, I can just reduce the size of this for a little bit and then expand the screen of the robot so I can better visualize it, right? So anyway, as I was saying, right, so we have to move to position number 1 to grasp the workpiece, right? So now you're gonna, since there's no obstacles here, you're gonna do an MOV to P1, right? And then when you get there, you're gonna delay by 2 seconds, right? And then after like the workpiece reaches P1, right, you want it to grip the workpiece, right? So now you're gonna, since you've opened the gripper here, right? Here you're gonna close the gripper so the robot can grasp the workpiece. So when I say H, close 1, right? And then now after you are done, you're gonna go to programming and then you're gonna compile, right? So one project successful, right? And then now we test our code, right? So the robot is moving, arrives there, it's grasping the workpiece, right? And then after it grasps the workpiece, right? So what are they saying after it's grasped the workpiece? So now they're saying the robot crashed the workpiece, right? And then the creeper closes, right? And then they're saying the robot now returns to its initial position, right? So as I said, your robot, it tends to take the shortest path, right? So now here, like let's say if there was an obstacle here, you can't just move it up to its initial position, which means you have to take it back home, right? So, which means from now on, when you move out of this position, right, to avoid like a collision with this stopper here, right, we have to move the robot using MVS a bit up. So you're gonna delay for 2 seconds, right, and then you're gonna do an MVS, right, position 1, right, at a height of -30, right? And then you'll delay for 2 seconds, right? So I want to show you now what's the impact of this step, right? So one project successful, I reset, right? And then I insert the workpiece, robot moves. So as you can see, so now it's here, like we're sure now that you don't obstruct anything, right? So now we can do an MOV, right? So the next work operating sequence is saying the robot will return to its initial position. So its initial position is the home position, right? So we have to move the robot back to P100, right? Which is our home position, right? And then when delay for 2 seconds, right? So now here I'm gonna comment these steps as moving back to the initial position, right? So now then again compile, right? And then so it's important to test, like always every time when you add something new, right? It's important to always test your code, right? Because if you like technically you can write your code like at once, but if you get like an error in your code, you won't ever know where the error is, right? So it's important like to write test, right? Instead of like having to write the code and then it gives you an error and then you don't even know where that error was made, right? So now after moving back to its initial position, right, they are saying the robot advances to the first magazine tube, right, so that the workpiece is above the magazine tube, right? And then they're saying the robot lowers linearly into the magazine tube, right? And then which means it has to lower in a straight angle, right? And then the gripper opens and then the robot drops the workpiece and then it returns to its initial position to wait for the next workpiece. So now here, right, they're telling us that the robot, so we've done this up until here, right? So the next step is saying the robot advances to the first magazine so that the workpiece is above the magazine tube, right? So now this is our magazine. So this magazine one, this magazine two, right? So we have never defined these positions, right? So now, which means we need to add the position that this gripper or this magazine, the first magazine, is located at, right? So which means we'll go back to our position list and update it to compensate for the new position that we need to go to, right? So which means we'll come to the positions, right? So which means let's close this for now, right? And then let's reduce this, right? And then we're gonna call back our teaching, right? And then so I'm just gonna reduce this so that we can see if the robot has reached this position, right? So now, as I said, like you can use these exits, right? So now if like they didn't give you, or in a test they didn't give you that position, right? You can use the teach in, right, to try and move to that position, right? So you can try and use the teach in, right, to move to that if you are not given that position, right, which is magazine one, right? So as you can see, like I can use the teach pendant like to move to that position, right? And then after like I'm satisfied, like so now as you can see, I can use the teach in, right? So it's a bit of a trial and error thing, right? So let's say in a test I didn't give you that particular position, which means you have to like move the robot to that position on your own, right? Let's just reduce the increments to one, right? Okay, and then so yeah. So as you can see, I've reached magazine one, right? Let me just confirm if so. Let me just move a bit down. Yeah, this height is fine, right? So now I'm just trying to like ensure. So now I'm just trying to confirm if there's perfect alignment, right? So I can just, so as you can see, it's a bit off here. So now let's see if I'm, so, mm, so now I have to ensure that like it's perfectly aligned, right? So as you can see, like I can now be sure that my workpiece is gonna fall in straight into the magazine, right? So, but I don't want this to be my P1 because it's gonna cause collision, right? So I'm just gonna move the robot like a bit up, like to think here it's okay, right? Because I know that if the creeper opens, the robot now will, the workpiece will now fall on straight to the magazine, right? But I've also in the guide, right? Like this position here, it's also a position that's used for what you call for magazine one, right? It's called PM1, right? But I want us to try and use this one that I've just created here, right? And then if it's somewhat inaccurate, right, we'll move to change the position, right, to the one that I've already worked with on the book, right? So now, so this is our, so you can try, so you can use this position that I just created, or you can also stick to this one that's given as PM1, right? Because here I'm currently using the studio version, and then you guys have the educational version. So I don't know, there might be a slight mismatch in the positions, right? So you guys, you can try this one, or you can try the one I'm using, and we'll see like you'll like see which one works best for you, right? But for now, let me use this one, and if it doesn't work, I'll switch to the one that like I've already worked with when I was using the studio version, right? So now, since I've already like moved to this position, so I'm gonna save this position. So I come back to my teach in, right? and then I'm gonna insert a position, right? So this is the position, right? And then I'm gonna left click, right? And I'm gonna go to properties, right? So when I get to properties, I'm gonna label this position as P5, right? So I'm gonna label this as P5, right? So now my P5, so I'm gonna label this as P, so I'm gonna call this magazine one, right? And then now we have our position that we're gonna use, right, for dropping the workpiece, right? So we're gonna return to following the sequence, right? And then we're done with this. I know, don't close it. This was a mistake, right? And then I'm gonna look for, just gonna create space like so that we can, and then we're gonna need our code, right? S- So now they said after we move back to the initial position, right? So I've already saved this position, so I can just reset, right? So here, going back here, right? They said the robot now advances to the first magazine, right? Which means I have to move to the first magazine from the home position, right? So now I'm gonna say comment by saying moving to the first magazine, right? And then now I'm gonna call this, I'm gonna say, so now we've delayed our move, right? And then I'm gonna do, like, since they said, like, here, if you look at this again, they said the robot should lower the robot, should lower the workpiece linearly, right? Which means first, to ensure that we also avoid obstacles, or we able to move the robot linearly in the workpiece linearly onto the magazine, right? Which means you have to do like a horizontal move, an MVS move to position number 6, right? Which is our magazine, right? At so now we've been using a height of minus, which is somewhere like lower here, right? Which means we have to increase our height. Let's say I increase my height to minus 200, right? So we have to do, we're doing a move to P6, right? The horizontal move to P6 at a height of minus 200, right? Which means it's somewhere like, since our 30 is somewhere here, our 200 will be somewhere here, right? And then when we get there, want to delay for 2 seconds, right? And then I want to run this. So I compile, so project successful, right? And then now I can, so now I can run my code, right? So now press play, right? And then robot is in the loop. I insert the workpiece. So now I want you to look at the MVS move to P6, right? So the robot is gonna move horizontally to P6. It's not gonna move straight to P6. Okay. So let's just say 150. Want to say something. And then so it's saying no configuration change within the part movement, right? So okay, let's see. Back to our pose. Oh, sorry. I said what you call magazine. I was trying to move to magazine one, right? So I said P6 here, right? As you can see here, it's P5, right? which means I'll change this to P5. Sorry, that was my mistake, right? And then anyway, like moving on, think now should work. It should definitely work, like I'm sure. So I want to update this back to 200. 200 was okay. So we're gonna start afresh, right? So I was fixing this 200 now. Okay, we have another error. So, okay. So this position, as you can see, this height of 150 is too high, right? So I'm just gonna try and let's try and reduce it to maybe 100, right? And then I'm gonna compile. So, cause the horizontal height is too high, right? And then after I compile, I'm gonna play, right? So I'm just reset first and then play. Okay, so yeah, I think 100 is okay, right? Although in the test I will tell you which height we should move to, right? And then now we can move linearly, right? Which means we can move in the Z direction downwards to position number 5, right? Which means now we can do an MOV, we can do an MOV to P5, right? So now since we are still grasping the workpiece, right? Testing, okay. So right, so sound has been restored. So now I can do a linear move to P5 and then delay for 2 seconds, right? And after I delay for 2 seconds, right, when we get here, right, the instructions are saying, like after a robot lowers linearly into the magazine, the gripper opens so that we are able to drop the workpiece, right? So now we wanna do an H open. We're opening the grip. H open one, right? And then now I want us to compile this, right? So successful, right? And then now we're gonna reset and then we're gonna press play, right? And then we're gonna insert our workpiece. Okay, so now it has moved to magazine one, but it's not properly dropping, right? Which means I'm gonna try and maybe the coordinate that I wrote was incorrect, right? Or let me just double check how far off I am. So this was the original coordinate that I was given, right? So it's fine. I can just update these coordinates, right? So I just go to properties, and then my x is 345.5. So it's 345.5, and then my y is minus 110, minus 110.8, right? And then my z, it's 329.9. And then now I have to see if I have to adjust my angles. So this one is gonna be 179, right? So you can adjust it like the old school way that, or the other way that I showed you, right? You can use this way, right? So yeah, think now. So after then I compile, right, to ensure that the new position has been saved, right? And then now let's see. Okay, so this is a position problem, right? So let me try and get the correct coordinate. Okay, so yeah, so let's continue. So like as you just noticed, like I've been struggling with the magazine position, right? So I think it's primarily due to a bug in the it's due to a bug in the software, right? But like for now, right, like with the with regards to the magazine, right? So okay, so let me try and explain. Let me try to explain how we'll solve this, right? So this is the new position, right? So this is the proper position that we'll be using for magazine one, right? So this is the position for magazine one, right? And then like now, like another like slight change, right, to how we review that code, right? So as I said, like as I previously said, right, that we have to always do an MOV, right, and then drop the product from above, right? But like here with regards to the magazine, right? So how we address that part, we're gonna bend the rules a little bit, right? So we have to now move how so it appears how we have to drop the part into the magazine. We have to move inside the magazine, right? And that's when we can drop the part, right? Which means now we won't do an MVS position from here to here, right? We'll just move straight to the magazine and the robot will move inside the magazine, right? So we'll just say MOV to P5, right, which is the magazine, right? And then after we get to P5 with delay, and then the gripper open, age open, sorry, delay for 2 seconds, delay for 2 seconds, right? And then the gripper opens, right? So that it can release the workpiece, right? And then after it releases the workpiece, the delay for 2 seconds, right? So let's just compile and run this and see how what I mean, right? So now, so as you can see, the workpiece has been dropped, right? So yeah, it has been properly dropped, right? So let me just run it one time so we can observe it from this perspective. So as you can see, we have to move for us to be able to drop the workpiece. We have to move to touch the magazine. That's why we just did a direct MOV move, right? So this MOV move, like it only applies to the magazine since there's a bug, right? But like the principles that I've been teaching you, they apply to everything except the magazine because of the bug. So as soon as the bug is addressed, maybe that's when we'll be able to do it like properly, right? But to address the bug, right? So we have to just do an move to P5, right? And then delay for 2 seconds, right? And then we're gonna continue, right? So here they're saying after the workpiece has been dropped, the magazine returns to its initial position, right? So now we're gonna we're gonna now return the robot to home, right? So first we're gonna do an MVS, right, from P5, right? We want to move slightly up from P5, right, to let's just do this, yeah, to a height of minus 100, right? And then so here I can comment this as moving back to the home position, right? So now let me just compile this, right, and then so you can see what I mean. Right, so I reset and then insert the workpiece. So you move slightly up, right, and then from there, from this position, so as you can see, we are at a height of 100 above P5, right? So from then on, we can delay for, let's say, 1 second, right? So let's say 1 second, and then now we can move back to home. So we can do an MOV back to home. Our home is our P100, right? And then we end the program, right? And then now if I reset and simulate, Sorry, I forgot to. Did I compile? Right, yeah. So I think now my code is compiled. So compiling is very important, right? Because if you update your code without compiling, it won't read the latest code, right? So now it moves back to home, right? And then the sequence is done, right? So now this is your solution for exercise number 2, right? And then now, say like for instance, right, wanted. Okay, so let me just start here. So now, as you can see, the robot is only like working one work cycle, right? And then after one work cycle, it's just stopping the sequence, right? So let's say you wanted it to, like, this is like, it's gonna be like the main topic of our next exercise. So like as it stands now, right? This is our complete solution for exercise number, what you call exercise number 2, right? But I just want to like give you, I think it will be a really good heads up, like to exercise number exercise number 3, right? So now, as you can see, our robot is currently working one work cycle and then it's stopping, right? But let's say you are trying to like make the robot like every time it receives a workplace, it starts the sequence on its own. You don't have to reset every time, and yeah, and all of that, right? So what we'll do, we will like we'll loop the sequence of the robot, right? Because at this point now, after it completes this sequence, it goes to end, which means it ends the program, right? And then that's it, right? So let's say we are looping the program, right? Let's say we want to start looping it from here, right? So we're just gonna do hashtag like asterisk, and then we're gonna say start, right? And then since like we're trying to make sure that our robot doesn't the code doesn't end, right? We'll loop the robot here, right? So we'll say here, go to hashtag start, right? So which means now, instead of our robot, like instead of like the code going to end, it will say go to, and then it will loop back to here, and then it will run the sequence over and over again. The code won't ever stop, right? So if I can just compile and demonstrate to you what I mean. So now I'll just be inserting workplaces. The robot will not stop on its own, right? So reset, and then now I just insert the workpiece. So now, as you can see, like the code is not stopping. Instead, the code like it's jumping back to where start is, right, to go on a loop. So don't ever stop, right? So now this is how you loop your code, so that like it runs so now like the robot just awaits the workpiece, and then after the workpiece comes, it moves. So like let's say now it stops, there's no workpiece, right? As you can see, it didn't stop playing, right? It just went back here, right? It's waiting for the arrival of a workpiece. So now the code, it's on a constant loop, right? So so yeah, it's important to understand this loop, right? So after After here, so like when we do exercise 3, like the loop is looping, you'll see the importance of looping, right? And then yeah, I think that's it for this video. I'll do exercise number 3 on the next video. Thank you for watching.